Let us look at solving a system of linear equations, part 2. So let's begin with a system of linear equations. 4x minus 3y equal to 3, 3x plus 4y equal to 4. Now we have to get rid of either x or y term. To eliminate the y term, we have to equate the coefficients. We can choose to eliminate any one of them. So here we have chosen y. Multiply the first equation by 4 and the second equation by 3. So 16x minus 12y is equal to 12 and 9x plus 12y is equal to 12. Now let's add the two equations. Now when we add, what happens? Minus 12y, 12y cancel out. And we end up with 25x equal to 24, which means x is equal to 24 by 25. Now we have to find the value of y for x equal to 24 by 25 by substituting the value of x into any one of the equations. So let's do that. 3 times 24 by 25 plus 4y equal to 4. That is 72 by 25 plus 4y equal to 4. 4y is equal to 4 minus 72 by 25. 4y equal to 100 minus 72 by 25. 4y is equal to 28 by 25. So y is equal to 7 by 25. So we have got both the x and y values which satisfy both the equations. Or we can also say point of intersection of the two lines, which are the graphs of these two equations. This is our first equation, 4x minus 3y equal to 3. And we have 3x plus 4y equal to 4. And the point of intersection is A is equal to 24 by 25, 7 by 25. As we can see, it is difficult to pinpoint the intersection on the graphs because it is not 1, it is just a little bit less than 1. It is closer to 0 than to 1. So we can't exactly pinpoint where this intersection occurs. Whereas algebraically, it is pretty straightforward. So hence algebraic method is preferred. Now, an assignment for you, or rather 2 assignments. Verify the answer, redo by eliminating x. Here we eliminated y term. Now redo the whole thing by eliminating the x term. Let's look at the next problem. Now we have a system of 3 equations in 2 variables. So we take any 2 of the equations and solve for x and y. So let us take the second and third equations. Multiply the second equation by 2. We get 2y is equal to minus 2x plus 4. And we have y is equal to 2x minus 1. Adding them both, minus 2x plus 2x cancel out. And we have 3y is equal to 3, which means y is equal to 1. Now substituting 1 in any of the second or third equations, 1 is equal to 2x minus 1, which implies 1 plus 1 is equal to 2x. We are taking 1 to the other side. So 1 plus 1 equal to 2x, which implies 2 is equal to 2x, x equal to 2 by 2, which is x equal to 1. So for y is equal to 1, we have x equal to 1. So the point of intersection is 1, 1. Substitute the values of x and y into the first equation and verify. So the point is, we have found the solution, that is x equal to 1 and y equal to 1. Now that we have the solution, we need to verify whether that solution also applies to the remaining equation. That is the first equation. Y is 1 is equal to x is 1. So 1 by 2 plus 1 by 2, which gives us 1 equal to 1. That means this solution 1 comma 1 also satisfies the first equation. Hence, we have verified that 1 comma 1 is a solution of the system of linear equations. And the system comprises of 3 linear equations. Now, what this also tells us is to solve a system of linear equations in 2 variables, we require 2 linear equations. Third one, actually, we don't require. But since this is a system of 3 linear equations, the third equation can be used to verify the system's consistency. If the solution that we arrived at using just 2 equations satisfies the third equation as well, the system is consistent. If the solution does not satisfy, then the system is not consistent. Now let's look at the system of equations given by y is equal to 3x plus 4 and y is equal to 3x plus 1. Now here we can directly subtract the equations. We get y minus y is 0, 3x minus 3x, 0x, 4 minus 1, 3. So we end up with 0 equal to 3. So here, when both x and y disappear, we arrive at a contradiction like 0 equal to 3. We say that the system of linear equations is not consistent, which means it has no solution. Pretty straightforward. The moment you see x and y both disappearing together, that means they are inconsistent. It is an inconsistent system of linear equations. Let's look at another system. 2y equal to 6x plus 4, y is equal to 3x plus 2. Multiplying the second equation by 2, we get the first equation itself. So let's multiply the second equation by 2. 2y plus 6x plus 4. So we are getting the first equation itself. Or if we divide the first equation throughout by 2, we get the second equation. That means their graphs are lying on each other, or the lines are coincident, or we can say they represent the same line. Since they are lying on each other, it means that every point on the line is a point of intersection with the other line, which is lying on top of it. Therefore, there are infinitely many solutions. Equations whose graphs are coincident are called linearly dependent equations. So here these two linear equations are linearly dependent equations. Equations whose graphs are not coincident are called linearly independent equations. We have seen through different examples that there are different types of solutions. We can have infinitely many solutions. We can have a unique solution or no solution. How to figure out that as fast as possible? So we convert the linear equations to slope-intercept form. y1 equal to m1x plus c1, y2 is equal to m2x plus c2. If the slopes and y-intercepts are equal, then they lie on each other. That means they are coincident. So the solutions are infinitely many. If the slopes are equal, but the y-intercepts are not equal, then the lines are parallel to each other. That means they never intersect, which means no solution exists. And if the slopes are not equal, then they are going to intersect somewhere. So there is a unique solution. Now, if the linear equations usually will be given in general form, that is ax plus by plus c equal to 0. So let us derive the expressions for the slope and the y-intercept from the general form of a linear equation. So general form is ax plus by plus c equal to 0. By just looking at this, we should be able to figure out what the slope is and what the y-intercept is. So we divide by b. Since slope-intercept form is y is equal to mx plus c, that means the y coefficient should be 1. So we have to get rid of b. So we divide the entire equation by b. So we get a divided by b times x plus y plus c divided by b is equal to 0. And now rearranging it, we get y is equal to minus a by b x minus c by b. Now this is in the slope-intercept form. And because we are dividing it by b, it cannot be equal to 0. So which means the moment we look at the general form of an equation, immediately you know that the slope is going to be minus a by b and the y-intercept is going to be minus c by b. So let's look at it through an example. 3x plus 2y plus 5 equal to 0. So immediately you know slope is minus a by b, which is equal to minus 3 by 2. And y-intercept is minus c by b, which is equal to minus 5 by 2. And the equation in slope-intercept form is y is equal to minus 3 by 2x minus 5 by 2. See, the point of this is that to figure out the nature of solutions, I said convert the linear equations to slope-intercept. Now, you can literally do this in your mind itself using these expressions. That was solving a system of linear equations part 2. That's it for now. Bye.